Okay, this was our another little thing that's important, kind of nice to mention whilst we have this code in front of us, is that this is input validation. There's a separate video how I came to that, to get an integer between 1 and 6, and this is type validation in particular. But the input validation I'm doing with terms of the numerical checks, this is, remember, that's input validation. You initialize to something invalid, and you while is invalidity. So this is an invalid number, which means it's a number that is strictly smaller than 1, or it's a number that is strictly larger than 6. So it's wrong one way, or it's wrong the other way. I'm very sorry, I'm going to be a... Whereas below, so it needs to be wrong. My number needs to be incorrect, which will initialize to -1 for me to go into the loop and to keep looping. And similarly, for me to display for the code, forgive me, to display the error message, I want to check on invalidity, except I've written it the other way. So this is validity. The number is greater or equal to 1, and the number is smaller or equal than 6. And bracket, bracket, not that. Those two things are equivalent, and it's something that's called DeMorgan's theorem. DeMorgan's theorem is so well known that I even trust Bing to give me meaningful results. It's written here in that algebraic notation. You can also see it in sort of set Venn diagrams, because those things are equivalent, and it's a not a bracket A or B equals not A and bracket not B, notated in that way in sets and in formal language. Yeah. So propositional logic, yeah. So there's a couple of ways of notating that, not just because there's a couple of ways of notating Boolean algebra, but because this is a theorem that touches many parts of, I guess, mathematics or logic. So here it is. Now, which one should I use? Well, to start with, I feel that, well, to start with, that's poorly formatted, right? We want space on either side of my operator, but even better, this should really be written as 1 is larger or equal to num, so that you get all of your arrows pointing the same way, and it's also from left to right in the order as which the numbers increase. Just nice little things like that. But then whilst you're here, you can make it even nicer. We can hide this. Yeah, full screen. You can then make this even nicer because Python will, again, didn't format it right. Python will allow you to actually write the mathematical notation and put both inequalities on the same line, and that still works. So because I like this, much more concise, much more elegant, I'm going to copy it. No, I'm going to paste it back. But now I'm getting the clipboard. I can paste it in here. Let's just make sure I've not broken anything. My number is, what do I want? I want to test that, and both we're all in happy territory. That was DeMorgan's theorem. I think it's on the specification of, certainly at Excel actually, the GCSE, but as you can see, it's not just an abstraction, it manifests in code like that, and there are better and worse choices of putting the same an expression that we evaluate the same thing, or the same expression in many ways. So that's the sort of implementation side of DeMorgan's theorem. That was it. See you for the next one. In the meantime, happy coding.